Hello all, thank you for joining us. Today we will be talking about open source MLOps on AWS. My name is Andrea Montano, I'm the AIML product manager within Canonical, and together with me I have Mark. Mark, would you like to introduce yourself?
I'm Mark Thomas. I'm a partner solution architect with AWS, and I have the privilege of working with Canonical on all things Ubuntu and integration of Canonical products on AWS.
Thank you, Mark, for taking the time. I think now you're immersing yourself into machine learning and machine learning operations. Today we'll be covering the AIML challenges as well as what production-grade AIML means. Then we will go further and focus on machine learning on AWS, as well as open source MLOps and open source MLOps on AWS. Before we even wrap it up and we get to a fun demo, we'll be talking about hybrid cloud and how machine learning works on that, and how Charmed Kubeflow, Canonical's MLOps solution, works on it. Let's not wait longer and talk about AIML challenges. AIML became famous a couple of years ago, and then generative AI and ChatGPT and all this story made a huge boom at the end of last year. However, when it comes to actually building projects, I think there are still a lot of challenges out there. On one hand, when we look at the people and people who could actually develop all these projects, there is a clear skill gap on the market from one hand. But then on the other hand, each project has multiple stakeholders that want different things or actually don't have them really well defined. When we look at the enterprises, from the other hand, they require a culture change in order to, first of all, accept what AIML brings to the table, but also to adjust their workflow such that it can easily be integrated. If we move to the projects themselves, there is a fast changing landscape, and the machine learning lifecycle itself is also complex, reason why often companies feel a bit overwhelmed. When we look at the tools themselves, there are clear needs for hybrid and multi-cloud needs, and this is why we'll be covering a bit of those as well today. If we look at the operations, which is something that we do care about and companies care about a bit more than we do, user management and how to actually enable machine learning for bigger teams has been a question for quite some time, but also maintenance and how to reduce operations is another story that people ask about. At the heart of any machine learning project, there is data. And often companies have highly sensitive data that they would like to build projects with, and we need to always ensure that it is secure. From another perspective, the volume of data has been constantly growing for the last couple of years. And dealing with both data variety in terms of data sources as well as data volume has been a bit of a challenge. Last but not least, companies have not been focusing on building or actually gathering data for quite some time. Reason why these days the cleanliness of the data is challenging. There are often missing values, duplicates, data that is actually not useful but is still stored and just takes space. And these are all challenges when it comes to kickstarting an AIML project. However, AIML is still a valuable, I would say, tool in various industries, from retailers who can do market basket analysis or customer personalization, to telcos who are already building self-organizing networks, or financial services who have been doing card fraud detection or, again, customer personalization for quite some time. There are a bunch of industries that benefit from AIML, and even more enterprises who are kind of embracing machine learning as part of their culture and part of their operations. The budget for machine learning projects have been growing constantly in the last couple of years, and I am quite sure that it will not stop here. However, companies are also looking for a return on investment for their projects, as well as production grade solutions that they could benefit from. So they are looking to, I think, shift from just experimentation to production. And when we think of why it is important actually, or what are some of the benefits, AIML started as a tool for research, and it's still an area where it's still highly used. Healthcare system has been, I think, leading the market, but then it often or it quickly moves towards personalized experiences in different industries. If you just think of all the stores that are recommending different tools or different items based on customer patterns, that's just AIML behind. But if you look on the other hand, industries such as telcos are looking at AIML because of sustainability reason to decrease their power usage, but also because of cost savings in order to turn off, for example, or turn on cell towers, depending on their needs, depending on its usage. The two items at the top, task automation and process improvement, I think are the ones that are more accessible for all AIML enterprises. For all enterprises when it comes to AIML, and this is why a lot of companies kickstarted initiatives. If we are moving further on Charmed Kubeflow options on AWS, I'll give it to Mark because he's the AWS expert.
Thank you. Today we're going to be talking a little bit specifically about the open source machine learning project Kubeflow, and I'm going to be zeroing in a little bit of that. And of course, my area of expertise is AWS, so we're going to talk about why run your Charmed Kubeflow on AWS and then how to do that. One of the advantages of open source AIML is, if you can go back just one slide, I'm sorry, but I don't have control of the slides, so she's going to be trying to read my mind here as we go forward. Apologize for that, everybody. One of the advantages of using open source tools for AIML is portability from one environment to another, from your on-prem environment in your data center to various cloud providers. This is especially true when running your workloads on Ubuntu because you can find it practically everywhere, and it offers a very consistent experience from one environment to the next. Since we're talking specifically about Kubeflow today, I'm going to spend a few minutes talking about the environments of running those workloads on AWS. And then we do have a demo coming up. I'm going to show you a quick demo of some of the deployment options. So this chart, I apologize if the chart's a little difficult to read. At the top, you can see some of the workflow-related services offered by AWS. The chart doesn't include all the managed ML services because those are out of scope today. The middle layer includes some of the frameworks that you're familiar with if you've worked with machine learning at all. And those are some of the popular frameworks that are supported on AWS for ML workloads. I'm going to spend most of my time today on the bottom layer. We are going to touch on Amazon EKS and SageMaker before moving to our demo. You might be, if you've worked with SageMaker at all, you might be thinking it's a competitor to Kubeflow, but it's really not that simple when it comes to these tools. SageMaker can build, train, and deploy your machine learning models with fully managed infrastructure, but it can also integrate directly with Kubeflow to give you more flexibility on how to do these things, and I'll touch on that more in a moment. So why choose AWS? You've probably heard or maybe even believe that on-premises is cheaper. Well, if your PC sitting in the corner of your office is sufficient for training your model, then I'm not going to argue that point with you. But chances are you're going to need more than that. If you're training a model with a large data set, you're going to need a lot of cycles. So it's going to have a larger footprint. And now we're talking about what you have in your data center that's available and how you're using it. Of course, the cloud in general offers an opportunity to use the infrastructure that you need, pay for it while you're using it, and then turn it off. And that's true of every cloud provider. If you don't have a massive pile of GPUs sitting around, then you can spin them up in the cloud. You can use them for your Kubeflow pipeline, train your model, and then turn them off. And you get even more performance on some training workloads at a lower price at AWS using our purpose-built training instance types. So let's talk about the P3 instance type with it's our GPU instance type. P3 instance types feature NVIDIA V100 Tensor Core GPUs. You can get up to 8 GPUs per instance and up to 1 petaflop of mixed precision performance per instance. P3 instances support the Elastic Fabric adapter, and using NVIDIA's NCCL library, you can scale to thousands of GPUs for distributed training. Okay, so on the next slide, you can see a quick example of what that looks like when you're running that on Kubernetes. You can create a node group in your EKS cluster that includes P3 instance types, and then your container spec for your training job, you just specify that you want to use those GPUs. Oh, so now let's be clear, GPU instance types are more expensive than other instance types. A P3 instance is going to cost you several times as much to run as an equivalent M5 instance, for example. But you can use spot instances, and in doing so, you can save up to 90% over the on-demand instance pricing. Spot instances let you take advantage of unused EC2 capacity at a reduced price. And if the capacity, the available capacity should drop, then you receive a notification that your instance will be terminated to reclaim the capacity that you're using. So you don't want to run that for stateful workloads like Kubeflow itself, but they're very well suited for stateless workloads like training jobs or things that are interruptible. And you can use a combination of spot and on-demand instance types as well. So the EKS spot instances are automatically tagged as such, and then you can schedule your jobs to run on those spot instances. If you want to know more about the using spot instances with EKS, if you can go back one slide, I've included a link to the EKS workshop there, so people can grab a screenshot if they want to know more about that. Okay.
It is, sorry to jump in, it is worth mentioning that also we can share the slides with the audience if they want to quickly access the link right away.
Very good. Okay, so another option for training your workloads are EC2's TRN1 instance types powered by AWS Trainium accelerators. Now, these are purpose-built instance types that are designed for AIML model training. You're not going to run, a regular conventional web server front-end workload on Trainium instances. The Trainium instance types could be up to 50% cheaper cost to train over comparable EC2 instance types. And to give you an example, I looked at the EC2 launch wizard yesterday, and the on-demand pricing for TRN1 2x large instance with 8 CPUs, 32 gigs of RAM was $1.34 an hour. Okay, so we've touched on the scalability offered by running Kubeflow pipelines in the cloud and the specific EC2 instance types that you may want to use. Switching back to Kubeflow, I want to touch on the integration between Kubeflow and Amazon SageMaker that I mentioned earlier. So instead of running your workloads in containers on top of EC2 instances, you might decide to offload the training job entirely from your Kubernetes cluster and use SageMaker to do it. Using SageMaker components for Kubeflow pipelines, your Kubeflow pipeline jobs can run on SageMaker, and you control them and monitor them from within Kubeflow. They don't run on the local cluster, and then the results are available within Kubeflow. SageMaker supports popular frameworks like PyTorch, TensorFlow, XGBoost, SparkML, and a lot of the things that you find within Kubeflow itself. So you've got flexibility to run your jobs the way that you want to. And the integration uses the AWS controllers for Kubernetes operators. The ACK operators allow Kubernetes to provision AWS resources using the Kubeflow API. And if you want even more flexibility, you can integrate Kubeflow with MLflow and SageMaker. And Canonical recently did a webinar on Kubeflow and MLflow, so I invite you to go check that out. Maciek Mazur and Kimonas Sotochos, apologize if I mispronounced your name. They go very deeper a lot deeper, into those projects than I could manage. So I invite you to check that out as well, and you should be able to find that pretty easily. And now I'm going to turn it back over to you.
Thank you. And you talked a lot about Kubeflow and about SageMaker, and it's worth mentioning that both of these tools are actually MLOps tools. And when it comes to MLOps or machine learning operations, it is a set of practice that aims to deploy and maintain machine learning models in production in a reliable and efficient manner. It is what we call these days the path to get production grade AIML. And I still shortly define it as DevOps, but for machine learning. When it comes to open source MLOps, the best part is that it's easy to use as well as for free. Everyone can try it out, and it's community driven. Mark already mentioned about the Kubeflow versus MLflow webinar, where we also discussed about the power of the community when it comes to machine learning tools. But it's also important to mention that it is supported, and in case you want to run it in an enterprise grade environment, there are options for that as well. So if we look at the why choosing open source MLOps, there are a couple of advantages. On one hand, it is price effective. You can start without investing on any hardware, especially if you go on AWS. But then it's also experimentation friendly. If you spin up a Charmed Kubeflow, for example, on AWS, you will get it up and running quite quickly. And then it is available on the marketplace, Charmed Kubeflow, and you have it within a few clicks. So you get rid of all the, I would say, burden to deploy a tool from scratch, but also it requires low maintenance. And by now you might wonder what is Charmed Kubeflow. It's an open source machine learning tooling. It's Canonical's official distribution of Kubeflow, the upstream project that was started by Google a couple of years ago. It is actually a suite of tools that allows you to both develop and deploy machine learning models um, on any Kubernetes cluster, and underneath we do allow any environment. Often we get questions on, hey, but what is the main difference between the upstream project and Charmed Kubeflow? And I often say it's more charming, but the truth is that Charmed Kubeflow is the foundation of a growing MLOps ecosystem within Canonical, and it benefits from a wide range of integrations. On one hand, we have observability available for Charmed Kubeflow itself by integrating with Canonical's observability stack that includes Grafana and Prometheus. But then we also have some other tools such as MLflow or Spark available. When we look at our partners, our other partners that Mark already mentioned, and I'm thinking now of NVIDIA, we also have some of their frameworks available. NVIDIA's Triton Inference Server is available through Kserve. But also it's worth mentioning that we do offer security patching. We offer enterprise support as well as managed services for those who are interested in it. When it comes to Charmed Kubeflow on AWS, we are happy to say that on one hand, we have it available as an appliance on the marketplace, which offers the full capabilities of Charmed Kubeflow, but it's easy to use. It's easy to install because it's just a couple of clicks and it's spin it up. It gives you it allows you as a user to be closer to your data sources, but also it's easy to maintain. Similarly to Charmed Kubeflow, it offers managed or support services, and it still stays community driven. It was really an idea that started because on the community itself, there are a lot of questions on how do we spin up Kubeflow on AWS? Can we use it? And then Mark today went a step further and talked or told us how we can actually use Kubeflow and SageMaker together on AWS. When it comes to the hybrid cloud itself, it is a story that, at least on our side in Canonical, we do get a lot of traction. I will assume, Mark, that you also see it from your side as well. And it is, yes, go ahead.
Oh, no, I was just going to weigh in and say yes. Hybrid cloud and multi-cloud is something that AWS hears from customers as well, because they want that flexibility.
And I think you're capturing it correctly. What they are looking for is the flexibility in order to get the model deployments faster, but also to get efficiency where it's needed. On the other hand, you enable infrastructure savings. You already talked a bit or touched a bit upon spot instances, but even having just AWS plus on-prem, it's something very valuable. And then when it comes to open source MLOps for hybrid cloud, it's very important to mention that there are no tooling constraints. So in terms of Charmed Kubeflow, you can run it both on-prem as well as on AWS, which gives you a wide range of flexibility. If you allow me to do a bit of wishful thinking, I think it would be interesting to see if we can have SageMaker plus Charmed Kubeflow on AWS, but also Charmed Kubeflow on-prem, and see if those work together. That might be a cool project to look after or to look into a bit after. But before we get into that, Mark, I know you've prepared a demo for us. Would you like to tell us a bit more about that?
Yeah, I'm going to talk very fast and go hands-on keyboard and show a couple of deployment options for Charmed Kubeflow on AWS. If everything goes as planned, we're going to run through deployment on our managed Kubernetes service, EKS. I'm going to show deployment on Canonical's microkates, and then run through a couple of the differences there and show the similarities as well.
Let's get it started, I'll say.
Let's get this demo kicked off. I've been asked to keep this to about 10 minutes. So I would show you a complete deployment all the way through with the EKS cluster and then Kubeflow, Charmed Kubeflow on EKS. But unfortunately, the EKS deployment itself, in my experience, takes about 20 minutes. The deployment of Charmed Kubeflow can take a half an hour or more, depending on how long it takes for the components to settle in. So I'm not going to be able to walk through this whole thing, even if we had that kind of time. No one wants to sit and watch software deploy like that. So what we're going to do is just start some things, and then we'll kick them off at various points, and we'll show you the pieces that I've already been baking and how this ultimately winds up. So to start with, this is the YAML that I use to define my EKS cluster. You can see here that I've got two nodes in two different availability zones. This add-on adds a persistent storage to the EKS cluster for Kubeflow to use. It actually executes both steps. It grants the IAM role permissions to the Kubernetes service account to manipulate AWS resources, and then adds the add-on to the cluster and adds the storage. You can see here I did not use Ubuntu on the worker nodes for this demo. Just briefly, that's doable, and Carlos Bravo at Canonical has created some excellent demonstrations for how to do that, as well as how to add Ubuntu Pro subscriptions to those nodes and take advantage of ESM and kernel live patch and so forth. For now, if I'm going to deploy this cluster, create cluster cluster.yaml. You can see it's loading CloudFormation in the background, and there are going to be two stacks that are deployed. One deploys the EKS cluster, the other deploys a managed nodes group. Now we're going to skip ahead. I have another cluster already deployed and ready, and I've also installed and bootstrapped Juju. Now, for those that are not familiar with Juju, Juju is the service orchestration software published by Canonical. It is free to use. It is multi-cloud. It can deploy things on AWS. It can deploy things on various Kubernetes providers. And I've already set this up with my credentials for my AWS account. It does use static key credentials at this time. Juju used that when it bootstrapped to the cluster to create credentials in the Kubernetes cluster and deploy a controller pod. I've bootstrapped this ahead of time because I don't want, there's not really a whole lot to see, and it does take a couple of minutes. For now, we're going to add a Juju model. By the way, we are going to have to dig in a little bit into Juju in this process, because this is how Charmed Kubeflow is deployed. I'm not a Juju expert. I can get enough of this right to get us through this, but I'm not the best person to answer deep Juju questions. I can tell you that adding a model creates a wrapper or a container for all of the, not container in the sense of EKS, but a wrapper or a namespace for all of the various components that are going to be deployed as part of Kubeflow. And then the last thing that we're going to do here is we're just going to execute a Juju deployment of Kubeflow, and we're not going to make any customizations at all on this. We're just going to fire this off with the defaults, and you can see it's starting to download the various software components known as charms, and then it's going to upload those to the various pods that it creates and start to run the installation hooks for those components. Now, while this is setting up, I'm going to open another window. That was a default no configuration deployment. It can get fairly complex. You can define a lot of configuration parameters for all of these various components. So you would want to study the Juju Charm documentation as well as the Kubeflow documentation on this. Wanted to show you this particular bundle because this actually has the MFlow configured and integrated here as well. You can deploy these additional Juju charms and relate them in, and it all works together, and the relationship hooks take care of the integration pieces. So that's something that would take even longer for us to deploy, so we're not going to get a chance to demonstrate that. Maybe if there's interest, let the Canonical folks know when you provide feedback on the webinar, and we can do some longer, deeper dive videos for the folks that are actually going to be working hands-on with this. For now, as you can see, it is uploading the various pieces, and if we were to say Juju status, we could see the various bits being uploaded and running their hooks, and at the bottom you can see the pods that are being deployed. You can easily scale out with Juju and add additional units and then this scale here would show more than one. For right now, we're just getting one of each component. This default deployment is not highly available by any stretch, except for what Kubernetes would provide by restarting the pods. So while this is running, this is going to take far more time than we have. So I'm going to pop over here to one that I already did. You can see this is all already deployed, and all of the components are showing active. Now I'm going to pop in here, and I'm going to ask Kubeflow to show us the endpoints. Oops. Show us the endpoints. There's one external IP right here. We're going to take this, and I'm just going to say export. This is the load balancer. That's our ingress point for this deployment. I'm going to set that there, and then I'm going to copy a Juju config command out of my notes here. And here is something that's going to set the public URL in OIDC Gatekeeper, and also set a username and password. Incidentally, yes, this is a public-facing user ID and password. Don't get any funny ideas, because as soon as we're done, I'm destroying these clusters. So I'm going to set that, and then I'm going to come over. I'm going to grab this URL, waiting for this to run. Here we are. Username, user123 at example.com, and password, what did we say? User123. And here we have Kubeflow deployed using the steps that I was showing you. We're going to say, we're just going to keep that for now. And here's our Kubeflow dashboard ready for you to add components and work with, all completely deployed by Juju. Not going to walk through this interface. It's beyond the scope of what we have time for today. Again, if you want some deeper dives on Charmed Kubeflow, let the Canonical folks know, and we'll see what we can publish on the YouTube channels. Now, one additional way that we have of deploying this that I want to run through is microkates. And microkates is a very small Kubernetes deployment that will run on a single instance. And so you can run this on your desktop, you can run it on premise, you can run it in a cloud instance, and it is a good way to get your hands on some things without having to deploy and manage an entire EKS cluster if this is a small scale experiment that you're doing right now, or you're just testing out the software. So we can say sudo snap install. Let me see, I think I was going to install a specific version of microkates, and I just need to check my notes here. Yes, we're going to install from this channel today. And there's a few hooks that have to run. Here, and then hopefully this won't take too long. There we go. I'm also going to say sudo snap install Juju, and this also is a classic snap. Now, based on my playing with microkates, I believe we need to wait for Juju to finish installing. We are running slightly over on the demo, so I apologize for that, but I think you're going to be interested in seeing what microkates here. I believe I have to add my user to the microkates group, and then we're going to do that so that it takes effect. And we're going to set the ownership of things just for good measure. Now I'm going to check on the status of microkates and see, okay, it is enabled. And we can see by running the kubectl command inside of microkates that we have a full, if very small, Kubernetes cluster here. Now, the next thing I need to do before we can deploy Kubeflow is I need to add a DNS service, an ingress controller, some storage, and the load balancer. So I'm going to do that, and this will take just a moment to come up when this is done. Just wanted, and we won't be able to bootstrap Juju until it does, but I wanted to show you that Juju is actually aware of microkates and is prepared to bootstrap to that as a supported cloud. Let's see. Okay. I'm going to okay. So it's come up, and now we have the storage and the load balancer and these things. Now we can say Juju bootstrap microkates, Juju add model Kubeflow. And then we want to deploy the same thing that we deployed. Oops, sorry about that. There. Now we're deploying, and we're not going to have time to watch this whole deployment take place about what this looks like. Now, I would be remiss if I didn't point out two other options for you to check out if you wanted to really get a good look at this without doing the deployment at all, and that is the MicroK8s appliance for AWS, where you can launch this and just have MicroK8s already set up for you. The other is Charmed Kubeflow on AWS. And this basically is brings up everything that we just did. A basic Kubeflow appliance for you to play with and use. This is an appliance. It's the appliance experience. Easy to set up and run, but you may find at some point that you may need to move to the complete deployment in a Kubernetes environment.
Thank you, Mark. This demo has been great, and I think we're getting close to an end because I'm trying to stay conscious of time. Today we've talked about open source MLOps on AWS, focusing on Canonical's solution, Charmed Kubeflow, but also how it could integrate with AWS's solution. On one hand, we had EKS, but also we talked a bit about SageMaker. And when it comes to why choosing open source MLOps on AWS, I think the strongest statement is that it's easy to use as well as easy to install, but also it supports hybrid and multi-cloud scenarios that both Canonical and the AWS have seen as being requested. Last but not least, whereas it is an open source tool, and I'm thinking of Charmed Kubeflow, that's community driven. At the end of the day, we do offer managed and support services on top of AWS solutions. And that would be it on my side. Mark, would you like to add something before we wrap it up?
No, I just wanted to say that this is a hot topic. It's a complex topic. All of the tools, and even with the simplifications that the Canonicals put in place for deploying them, there is still a bit of a learning curve. So if you want to spool this up today, the appliances are a good option for standing up either the Charmed Kubeflow or the MicroK8s appliance, and then deploying your what you want on top of that. And then when you're ready to go big and go into production, then the full Kubernetes of deployment is there waiting for you.
Thank you very much. I think this has been it on our side, but if you would like to hear more topics or to learn more about open source MLOps on AWS, leave a comment, ask a question such that we learn from it, and why not having a second webinar as a follow-up on this one. Thank you very much and have a good day. Bye-bye.